Hey everyone, welcome. My name is Adam Keller and I'm a developer advocate on the Container Services team here at AWS. Today we're going to be talking about supercharging your ECS applications with the AWS CDK. We'll walk through what it takes to deploy a couple of common patterns and we'll demo them live. By the way, follow me on Twitter at RealAdamJKeller if you want to follow anything related to containers or anything I'm interested in. So on the agenda, I'm going to talk about ECS briefly, just do a high-level overview, and we'll do the same with the CDK. And then we're going to talk about two common patterns that are defined in the ECS patterns module, and then we'll end up with some Q&A at the end. So Amazon ECS, or the Amazon Elastic Container Service, is a highly scalable, fast, fully managed container orchestration service. With ECS, you can run your containers on serverless infrastructure with AWS Fargate, or have more control over your infrastructure and run your tasks on a cluster of EC2 instances that you manage. With ECS, there's no cost to use the orchestrator. You only pay for the resources that you use, such as Fargate and EC2. Being that ECS is a foundational service that powers other AWS services like SageMaker, Amazon Lex, as well as Amazon.com's recommendation engine. It natively integrates with other AWS services such as Identity and Access Management, Secrets Manager, CloudWatch for metrics monitoring and logging, auto-scaling, and much more. Being so tightly integrated in the AWS ecosystem, ECS can quickly integrate with other AWS services as the need arises or as new services come into the market. So now let's talk a little bit about the CDK. The AWS Cloud Development Kit, abbreviated as the CDK, it's an open source software development framework to model and provision your cloud application resources using familiar programming languages such as TypeScript, JavaScript, Python, Java, and .NET. Provisioning cloud applications, it can be challenging. It's a process that requires you to perform manual actions, write custom scripts, maintain templates, or learn domain-specific languages. The AWS CDK uses familiarity and expressive power of programming languages for modeling your applications. It provides you with a high-level components that pre-configure cloud resources with proven defaults. I call this opinionated tooling. So you can build cloud applications without needing to be an expert. You'll hear me reference these components throughout the tech talk as high-level constructs, and these constructs are a basic building block of the AWS CDK and of CDK apps. So a construct represents a cloud component and encapsulates everything AWS CloudFormation needs to create the component. A construct can represent a single resource, such as an Amazon S3 bucket, or it can represent higher level components consisting of multiple AWS CDK resources. Examples of this would be if you had a worker queue and its associated compute capacity, which, spoiler alert, we're going to talk about today and demo. It could be a cron job with monitoring resources in a dashboard, or even an entire app that spans multiple regions and multiple AWS accounts. Lastly, the AWS CDK provisions your resources in a safe, repeatable manner through AWS CloudFormation. It also enables you to compose and share your own custom components that incorporate your organization's requirements, helping you to start new projects faster. And when we say that, we're really just talking about these high-level constructs that you can build and reuse across your organization. So now I want to talk about common patterns, now that we have an understanding of ECS and the CDK. So within the CDK, and by the way, this is the link to the CDK documentation, the API reference, really good place to find any type of constructs you're looking for or modules that you want to use to build your resources. But specifically what we're going to work with today is the AWS ECS patterns module. This module contains high-level constructs that will build ECS environments based off of common patterns. And we're going to build some of those common patterns coming up in the next couple of minutes. The two specifically that we're going to focus on Number one is going to be an application load balance service, and number two is going to be a queue processing service. But as you can see here on the screenshot from the documentation, there's a couple other high-level patterns that are available to you as well. So, as I mentioned earlier, you have the power to choose out of a handful of programming languages supported by the CDK. With that said, I like Python, and so everything we're going to demo going forward will be in Python. So the first pattern we're going to build is an application load balance service. When building this on my own, I need all the networking components, VPC, subnets, a load balancer, target groups, an ECS cluster, an ECS task definition, an ECS service, IAM roles, security groups, and other things that I've likely missed. Let's look at what that would look like visually in a diagram. So first I need to provision an AWS account, and then I need a VPC. Within that VPC, we want to deploy across multiple availability zones. And with each availability zone, we generally have public subnets and private subnets. The public subnets are where I'm going to have NAT gateways to allow my services running on my private subnets to egress out to the internet if they need to pull down packages or any type of updates. And then I have an internet gateway, which is allowing for anything that I run in the public subnet to ingress into my public subnet, which is where my application load balancer will live. I need to have an ECS cluster, and an ECS cluster is simply just a logical representation, a logical namespace where your containers will run for a particular environment. And then I need a service, and that service needs to point to a task definition. And then we deploy, based off of the service, we deploy n number of containers or tasks. Lastly, I need to ensure that my load balancer can talk back to those containers via the target groups. So as you can see, there's quite a bit of setup that goes into this, and we're going to look at how many lines of code it takes to get this built. Anyone want to guess? Waiting. Okay. So to create this in a stack of a front-end application load balance service using the application load balance Fargate service construct, in 10 lines of code, I'm able to create this environment here. Pretty cool, right? So now what I want to do is I actually want to demo this and show you how we can actually do it in real time. But before we do that, I want to point out one thing, which is our task image options. So I'll talk about this a little later, but specifically here, what we're doing is we're pulling down a Docker image from upstream Docker Hub. Keep an eye on this because in the next demo, we're going to do something a little different that makes the CDK even more powerful. And frankly, I just think it's super cool. So let's get into the demo. Okay, so now what we're going to do is we're going to build and deploy a load balanced web application as a Fargate service using the common pattern and the construct, the application load balance Fargate service. So the first thing we're going to want to do is I'm going to create a directory for my new application, my new project. Let's just call it ALB Fargate. Now, we're going to navigate into the ALB Fargate directory, and we're going to run a command, CDK init, which this will initialize a skeleton project for us. And we're going to define the language, because if you remember, I like Python. And we're going to hit enter. Now, moving my screen up a little bit, you can see it gave me some nice output. By the way, everything that it outputted is available in the README that it creates. Perfect. Okay, so if we look through the project a little bit, let's talk through some of the components. One, you'll notice we have the app.py. This is essentially the main of our application. So all of our CDK logic for different stacks may live outside, but within the app.py, this is what the CDK we're going to use to deploy our CDK application. And then we have a requirements text as well as a setup py. This is all just to help us make this software reusable. And of course, to install the components that we need for this to work. So if I go to the setup.py, you can see we have install requires. I would still need a couple more. So I'm going to use AWS ECS patterns because that's one of the modules I'll be using. And then also I'm going to install the AWS EC2 module. Now the reason for this is I'm actually going to be reusing a VPC. And the reason for this is basically just for the sake of time in the demo. I don't want to wait for the VPC to come up and be built because that takes an extra few minutes. Okay, so let's first look at we're going to open our app.py and then we're going to open up our actual stack configuration. So if we open the app.py, you can see here, very simple, straightforward. It gives us a starting point with our imports as well as the Fargate stack Python module that it created in a subdirectory, which we'll look at in just a moment. So you can see it's calling that module and it's importing that class, which is going to build our stack. We then instantiate the CDK app. We then call that class and we pass in the context, the scope, as well as the name. So this will be your stack name. And one other thing I'm going to add here, because I'm referencing, in just a moment, you're going to see I'm going to be referencing a VPC that's already built. I have to set the context of my environment. This is very important because the CDK, when you start to import resources, it needs to explicitly know what environment, what account, what region you want to query for these resources in. So we're going to look at that in just a moment, but let's go to pass in env, and there we go. So now let's also confirm that I have my env variable set. Let's see, CDK, and I do. Perfect. So we're in good shape here. And if you see here, that looks good. So we're just going to import the OS module as well. Okay, let's dive into the ALB Fargate directory and look at our stack that the skeleton project created. So again, it starts with our imports. So we're importing core. Core is the kind of core module of the CDK, but we're going to be using the AWS ECS patterns module as well as the AWS EC2 module. The AWS EC2 module is going to be for the VPC import that we're going to do. And then the ECS patterns module is essentially going to be that application load balanced Fargate service construct that we're going to deploy. So let's get right into it. Now, I do want to, I'm going to open this up. Let's see here. Okay. Perfect. Okay. So now that we have this here, we're going to just name our variable. So let's just name it, we'll just name it web service. And we're going to call the AWS ECS patterns module. And then we're going to say application load balanced Fargate service. Okay. I am using Cloud9 as my IDE, by the way. So which is AWS native interactive development environment service, Cloud9. All right, so we're passing in the scope, and then we're going to just name this web service. And now let's pass in some parameters. So it's pretty straightforward. There's not a whole lot that I want to do outside of the box here. And remember, I mentioned that when you build in the CDK, you can go with the opinionated nature of the CDK and use a lot of the opinionated internal constructs that are there. But you can also extend them and add to them as you see fit and based on the needs of your organization, of your team, etc. So we're first going to define our CPU. I'm going to go with a half of a vCPU, and then we're going to define our memory, which will say 1 gig. One thing to note, because this is a Fargate service, Fargate has CPU and memory combinations based off of the size. So if you select a certain CPU size, you're limited to a specific range of memory size as well. And that just comes down to the underlying instances that get deployed to support your Fargate service. This is how we can determine sizing on them. Okay, so then we're going to set our listener port. Now our listener port here is going to be 80. The listener is at the load balancer level. So I'm exposing my load balancer on port 80. And then we're going to go with some task image options. Now, with ECS, when you deploy a task or a service, there's a task definition associated with that. And the task definition defines what container or containers you want to run together, the sizing of those containers, as well as any other details that you may need to add to your container. For example, if you wanted to add a custom command on startup, you could do that in the task definition. So one thing that's really cool about the CDK is oftentimes you will notice that within a construct, one of the parameters will call another construct. So it's just a way to make things easier when building out your resources using the CDK. So I now have to call the application load balanced task image options. And this is essentially going to build a task definition for me. And I'm just going to pass a couple of parameters in. So one, I want to set the container image. And I'm going to say from registry. So I'm calling the container image construct. And then one of the methods is from registry. So I'm just going to pull it from upstream latest. So what I want to do is actually, we're going to Google this Cloud CMD. Oops. And we're going to pull this image from GitHub. From Docker Hub. Okay, so this is our image. It's just Cloud CMD. Actually, let's find the exact one. Here it is. Perfect. So this is the Docker image we're going to build, or we're going to deploy. So we're saying from registry, this is our Docker registry, and I'm going to add a tag there too. I'm going to say, let's get the latest. Now, if you've ever listened to me talk about containers, one thing you'll hear me preach is if you are deploying to production, you don't want to be pointing to the latest tag. There's many reasons, but one that just sticks out is that when things go wrong, when you're pointing to a latest tag, it makes it hard to find the problem. What change that could have possibly caused the problem in your environment. So generally there's semantic versioning or using a git SHA as your tag. It allows you to be able to know what version of code you're running on that container so you can very easily troubleshoot and get to the root cause. Okay, so now we're also going to define our container port. So this is going to run on 8000 and that's it. So looking here, we have our CPU, our memory limit, listener port, our container image, which we're pulling from a registry, and then our container port. So this looks pretty good. And one thing it's telling me is I didn't import the AWS ECS module, which I did. So this is why working in an IDE is so helpful, because it tells me my mistakes before I actually run the code. And that's it. So, and you know what? I did forget one other thing, is I do want to import that VPC. So what we're going to do is we're going to say VPC, and then we're going to say AWS EC2 VPC from lookup. And specifically here, what I want to do is I want to pass in let me take a step back. A lot of constructs have this from lookup method, where you could be building something, but you need to import a resource as a part of your build. So a great example here is a VPC, because in a VPC, I may be working in an organization that has a networking team that builds and manages VPCs. So I may want to just import that VPC into my build logic. So rather than having to do some complex code in Bodo 3 or something crazy, I simply call this VPC from lookup method, and then it will import that VPC into my code. So when resources are built, they know what VPC to build and deploy in. Okay, so what we're going to do is we're going to look up by VPC ID, and what I'd like to do is go to the console here, and we're going to find our VPC. Okay, so we go to VPCs, and you can see I have this VPC right here. This is the one I just created. So we're going to copy that, and there we go. Okay, VPC ID. Perfect. So this is everything that's going to that we're going to use to deploy our entire environment. Now, if you remember that diagram, we had a load balancer, target groups, containers, task definitions, service definition, security groups, everything that we needed to connect all the pieces together and to build all the components, the CDK is going to take care of for us. So this is looking good. So what I want to do now is I'm going to go back to the command line, and I'm going to run a CDK synth. Now, CDK synth, this command, what it does is it's essentially going to take my CloudFormation, or take my CDK code, and it's going to synthesize that into a CloudFormation template. And as we can see, this is great. It has my ECS service, my task definition execution, the role execution policy, all this stuff that I'd have to generally figure out on my own if I were to build this from the command line, the console, or anything else. But the CDK does all the heavy lifting here. It's creating a load balancer, syncing that load balancer to a target group, which then registers my services into. So this looks great. I'm ready to deploy. But before I deploy, I want to see if I have anything out there that exists right now. So there's the CDK diff command. This will essentially diff what you have in your local code and propose what's going to change based off of what is deployed in CloudFormation in your environment. So as you can see here, this is a brand new deployment. It's creating some IAM roles and policies, creating some security groups, and then a load balancer, IAM, really everything you can think of that you would need to get your web service up and running behind the load balancer and ready to rock and roll. And the one thing that's not being created is a VPC, and that's because I imported that resource from an existing VPC. So I am ready to go. So we're going to say CDK deploy, and this is going to synthesize that code into CloudFormation. It's going to then push that CloudFormation to AWS and deploy it. One thing I want to point out is when I ran a CDK deploy, because security changes are being made, security groups are being updated, changed, and IAM statements are being created, changed, modified, whatever. This is prompting me before the deploy. So I'm good with these changes. I'm going to hit yes. Now, one thing I could do is I could simply, on a CDK deploy, I could pass in a -- required approval never, which would essentially say, I don't need you to prompt me, just get this deployed, get this going. So now we're going to wait a couple minutes while it deploys all the resources. You can see there are 16 total resources that are being created. And you can see in real time, it's giving me an update as things are building. I will tell you, when it comes to creating a service like this, the one component that takes the most time to deploy is the Elastic Load Balancer, the application load balancer. So that'll take a couple of minutes. So what I want to do is now go to the AWS console and show you a couple different things. One, if we look at the CloudFormation console, you can see here's our stack. It's being created as we speak. So I could drill down, and everything I was seeing here, okay, in this live feedback from the command line, I can also view in the console in CloudFormation. I can see the events, I can see what resources have been created, and so on. So looking back now, I want to go and look at our ECS console. So you can see it has created the cluster, okay? And what's happening is it hasn't created the service yet because it's waiting for that load balancer to come up. Because in order to register our service to a target group, we need the load balancer to be created first. And so that's what's happening as we're sitting here watching this unfold and deploy. So let's go back and just look some more at the CloudFormation and see where it's at and what's happening. And actually, we'll also look at the load balancer too. But what's nice about the CloudFormation console is I get a nice visual representation of what's happening in the user interface. But you can see everything that's been created. Our task definitions, the roles, the IAM roles, security groups, quite a bit has already been created, the ECS cluster, and so on. So let's go to resources here, and let's see if we can find our load balancer. And it looks like it actually was already created. So now we should see our service get deployed. And there it is. So our service has been deployed. So if we drill down into the service, you'll see it's spread across 2 private subnets. It has a security group that connects the load balancer to this service only on the port that we've allocated for this service. We can see if there's any tasks running. We have a task, it's in a pending state. So our service has come up. It's now, the orchestrator has recognized that we have a service running that has one task desired. The orchestrator will now launch that task. But you can see that it created the log group. It created all of those necessary components and that boilerplate that I didn't have to think about. So I have my service, looks like my task is running now. I don't know if we have any logs yet. It looks like there's our first log. So our service is running. Let's take a look and actually go to the load balancer and confirm it works. So actually I went back to the command line here because one of the outputs is the URL of that load balancer. So if I click open, there it is. So I launched a container based off of a container image called Cloud Commander. It's an open source cloud file system. But here you are. Here you have it. So with how many lines of code was that? I want to say 10, maybe a little more. I was able to deploy a web service behind a load balancer via a container in a VPC that I already had built with my resource requirements, my container image, my port, and that was it. And in a matter of a couple of minutes, it spun up all the necessary resources to have my service up and running. So you can see this is just exposing the file system of that particular container. But there you have it. So that was our first pattern that we used to deploy a web-facing service. So let's go back to the slides and let's talk about our next demo. For our next demo, we're actually going to build a queue processing service. So let's look at architecturally what it takes to get a queue processing service up and running. So very similar to the application load balance service, we need we need to provision our AWS account. We need that VPC. We want our subnets across multiple availability zones. If somehow our services do need to egress out on the internet, we need to make sure we have NAT gateways, internet gateway, the ECS cluster, ECS service, and then a task definition that service points to. And then we want to ensure that our service is running n number of tasks or containers. And lastly, we want to make sure we have our queue. So we need a queue that our service can talk to, as well as a dead letter queue in case our service can't process a message after n number of attempts. That message will get moved to a dead letter queue for further review. Again, when looking at this environment, you have to provision all the networking components, the ECS components, but specifically what is kind of boilerplate / tricky to understand or have to figure out on your own is connecting your ECS service and those tasks to that queue in SQS. You need to make sure that you have the IAM role assigned to that task definition. So when that task runs, it will have the permissions to read from that queue in SQS, as well as once a message is read, to delete that message. So there's quite a few nuances that you have to set up and ensure that your service can actually talk to the queue and do what it needs to do. So just like last time, I'm going to give you a couple seconds here to think about how many lines of code you think it takes to build this environment. Drum roll. Looks like 10 again. So this is, again, using that high-level module, the AWS ECS Patterns module, and we're using the queue processing Fargate service construct, which is going to build everything that I pointed out in this environment here, but it's going to build it in less than 10 lines of code. Now, if you remember from the last demo, I said keep an eye on the image that we were sourcing from Docker Hub. You may notice it's a little different here because in the container image construct, instead of saying from repository, so instead of just pointing to an upstream image, I'm actually saying from an asset which is local on my file system. And what I've done is I'm saying here's the directory where my Docker file lives, and here's the name of my Docker file. And so what will happen is the CDK is actually going to run a Docker build. It's going to tag the image appropriately, and the tag will be the git hash of the current commit, and it will push that image to ECR, our Elastic Container Registry. Not only will it push the image to ECR after it's built, but it's going to ensure that our ECS cluster, our tasks, our services have the permissions to pull down that Docker image. So just another thing that the CDK does that while it seems pretty simple and straightforward, I think this eliminates a few lines of bash code to try to get all that stuff figured out and set up. So let's go into the demo and now build a queue Fargate service. Let's do it. All right, so now we have our directories here. You can see we have our Fargate ALB service that we deployed. So let's go ahead and initialize a CDK app for our queue service. Okay. So we made the queue service directory. Now let's go ahead and run a CDK init, and we're going to say language is Python. This will generate our project structure that we can work with. And let's start with our app py. And you can see here, very similar to when we deployed the front end. The one thing I want to do though is, like I did with the front end, I don't want to deploy a VPC just because of the time constraints with the demo. And I want to make sure that I pass the env into the app, the stack that we deploy. Perfect. Okay, so that's our app.py. Now let's open up the queue service stack.py. And what we're going to do is we need to import a few resources that we're going to need. So I'm outside of the core module with CDK. I want to import AWS ECS, AWS ECS Patterns, and AWS EC2 because I'm going to import the VPC when I create my environment. So now we're going to create our code, which I'll let you be the judge of how, if it's too long or not. So we'll start with self.fargate queue service equals, we're going to call the ECS patterns module, and we're going to look for the queue processing Fargate service. And again, there's an EC2 service, which if I wanted this to run on EC2, I could do that as well. EC2 meaning an EC2 backed ECS task or service. So we'll call this queue service. And then we're going to define our CPU. I want a half of a vCPU. And then our memory, I'm going to say 2048, so 2 gigs. Because this requires a little more processing power. And then our image. So I'm going to put a Docker file in this directory. And as I mentioned in the slide, CDK is going to build this Docker file into a Docker image and then create a container repository in ECR and push that image to ECR for us. So AWS ECS, and then we're going to say container image, and we're going to say from asset because the Docker file is local and it's going to create that asset locally. The directory, we're going to say the present directory that CDK runs in. And we're going to pass an exclude. So one thing to note is when you have your Docker file in the same directory with your CDK code, what happens is the CDK keeps trying to create assets in the cdk.out directory because that's where all CDK assets are stored. And it kind of creates this circular loop that just causes the build to fail. So we just want to make sure we exclude that directory. Okay, next I want to set the desired task count. We're going to set it to 1. And I think that's pretty good. The last thing we want to do is get our VPC like we did earlier. So let's insert that VPC there. So we're passing in the VPC that we want to deploy this service into and this cluster and all the dependent resources from a networking perspective. And that looks pretty good to me. So let's get our Docker file set up, and let's also get our code, because our Docker file is actually going to deploy, let's see here. It's going to deploy a service that I wrote, and I'll show you in just a moment. Nothing crazy, but it's just a service that essentially will pull SQS and then read messages as they come in. And once the message is read and processed, it will delete the message from the queue. And in this Docker file, I'm just pretty simply creating off of an Alpine image, installing Python, I'm pip installing Boto 3, and then I'm just copying this particular service code from the file system into the Docker image. And then the command we're going to run is that qservice pi, and then we're going to pass in a parameter of receive, which is indicating that it's going to receive and pull for messages. So let's see, qservice. Let me just make sure. So this should be qservice here. Perfect. And lastly, I need the actual service code itself. So let's go to the qservice. I know my naming is all kind of similar, which would arguably be kind of annoying, but in the case of a demo, it's okay. So we're going to just make this executable. And I feel pretty good about all of this code. Let's see if it actually can synthesize and get me my CloudFormation templates like I'm hoping for. So we also need to import OS. Okay. So let's run a CDK synth and let's see what happens. Assuming everything's good, we should see some CloudFormation. And indeed we do. And you can see it outputs the 2 queues. It creates a dead letter queue as well as the main queue. It gives me the ARNs as outputs as well as the name of those queues. And if I were to pipe this, so this goes to the cdk.out directory. And if I were to just see how many lines there are, 506 lines of JSON CloudFormation, that 10 lines of code created. Okay, so with that said, let's run a CDK diff to see if I have an environment deployed, what changes are being proposed. I don't have an environment deployed, so it's going to create all new resources. And you can see here. So let's go for it. CDK deploy. And we're going to say require approval never. So just in this situation, I don't want to be prompted for any security changes like IAM or security groups. So let's just go for it. And what it's doing, as you can see here, is it built our Docker image, it pushed it to ECR, and now it's going to deploy the CloudFormation to make sure that our environment gets built. But pretty neat that I didn't have to run a Docker build. I didn't have to think about the tagging. It just took care of all that for me by simply pointing to a Docker file locally on my file system. So super neat, and just kind of one of those, just nice things that you find with the CDK as you start building and iterating on it. So if we go to back to the console here, and we take a look at our clusters, we should see we have a Q cluster that came up. And that was pretty quick. So our Q, it's actually, just kidding. It's not up yet. That was an old one. But we do have our Q cluster. And you can see we have our service deployed with a desired task count of 1. And if we drill down to that service, we can see have any of the tasks deployed. So the task's in a provisioning state. While that task comes up, let's go to SQS and see if we actually have any queues waiting for us. And we do. That's pretty awesome. So we have our dead letter queue and our main queue. What I'm going to do is copy this name because we're going to use it in a moment to show that we can send messages to the queue and then to show our service process those messages. Because what you'll see is the service won't show anything in the logs because nothing is in the queue yet. So what I want to do is I want to go back to my code, but it's going to take a moment for everything to just wrap up and deploy. So we're going to go here. We'll go back to the queue service. And if we run queueservice.py, it's going to say send or receive. So one thing I know is we need to export queue name equals the name of the queue. Oh, and by the way, something I forgot to mention is going back to our ECS service as just a nice thing to do from the CDK folks is our service has an environment variable. If we go to the task definition, that actually has the queue name in it. So this is accessible via my task. Obviously, I don't want to hard code a queue name in there because as I deploy to multiple environments, queue names will differ. So this allows me to essentially just in my code look at the environment variable queue name and know that the CDK is going to ensure that that value is properly set for that key. So just another cool little feature that comes with these high-level constructs. So going back to the cluster, we'll go back to our service, and then we'll actually look at the task, and we'll see again, logs, nothing's going on. Okay, so let's go back to this, and we're going to run queueservice.py, and we're going to say send. And we just sent 100 messages. We're going to send 100 more, and we're just going to send. We're going to keep it going. So what's going to happen now is our service, our SQS service that we deployed, is actually going to pull, and let's just confirm that we have messages. So I sent 500 messages, and you can see it's already processing those messages. But one thing to be honest, I don't even remember if I mentioned it or not, is, and you can see, boom, here's our logs. So it's already starting to work through those. One thing I'm not sure if I mentioned is the auto-scaling piece. So when you look at this service, one thing that we have to think about when we're building our services, deploying our services or containers is how does my application scale to meet the demand of whatever it is that my service is responsible for. So in the case of a load balance service, I may want to scale on influx in network traffic through the load balancer. But for a queue, I'm most likely going to want to scale on queue depth as my metric. So what happens with this particular construct is it enables service autoscaling for you. So if we drill down into the service and we go to the autoscaling tab, it actually enabled autoscaling based on the queue depth. So it creates a target tracking policy, and if your service is not able to process those messages within the threshold, it will actually scale your service up for you. Now, the minimum and maximum, the default is just up to 2 maximum tasks, but you can override that with the CDK, because remember, the CDK gives you a set of defaults, but you have the power to override those defaults in your code. So as you can see here, it created a step scaling policy, it created the alarm, and it did all this for us without us having to even think about it. So if we look at tasks right now, we can see we just have the 1. And I believe this actually, it takes about 5 minutes for the auto scaling to kick in. But I'm just going to keep sending some more messages so we keep that queue up high. And I want to look at the alarm, and let's see what that actually, what's happening with the auto scaling metric right now. So if you go to the alarm, it creates a CloudWatch alarm. And you can see right now there's not enough data in that alarm. It's most likely going to take a few minutes because it's waiting for more data to come in and for it to be able to determine whether or not an alarm needs to be triggered. So you can see here, it's just sitting in a state right now of insufficient data because it just doesn't have enough data to register yet. So that's it. What we did was, through 10 lines of code, we were able to deploy a Docker image, create a Docker image, create an ECR repository for that image, ensure that that image can sync with the ECS cluster permissions-wise, and then also deploy a queue, a dead letter queue, sync the queue with the service to ensure that the service can read messages from that queue. And that's about it. And we built this all in a VPC that already existed. So we showed that we can import a resource from outside of our stack and deploy our environment to that particular resource, which in this case was a VPC. Or I should say, include that resource in our deployment code. So that's it for this demo. I'll refresh one more time just to see if anything's changed from a scaling perspective, but that's really it. So let's get back to the slides. So that wraps up the demos and the tech talk. I want to end with some resources to help you get started with CDK and with ECS. So first we have the GitHub project for CDK, the CDK documentation, that API documentation that I was referencing earlier with the AWS ECS patterns module, and then the front page for Amazon ECS. We also have workshops available to get you started with using ECS and using CDK. So if you just want to get familiar with the CDK, there's the cdkworkshop.com. And if you want to get familiar with deploying ECS, but also deploying it using the CDK, head over to ecsworkshop.com, where we'll walk you through how to deploy a 3-tier polyglot application with 3 microservices, all using ECS, all deployed via the CDK. And lastly, we have our roadmaps. They're publicly available. So if there's something you want to talk about, something you're interested in, or if there's a feature that you feel like is missing, go to one of our roadmaps, whether it's the containers roadmap or the CDK roadmap, and input your feedback, because we do take that very seriously, as that helps drive our roadmap as we build on. So that's it. I want to thank everybody for spending the time with me today and watching this tech talk. I'm going to open it up for Q&A, but if you have any questions, please feel free to reach out to me via my email, follow me on Twitter, or check me out on GitHub at Adam J. Keller. Thanks so much.